Welcome! We're going to review solving quadratic equations in this lesson. So let's first of all state the 4 ways to solve quadratic equations. I'm going to list these in the order we learned them. They also happen to be listed in their order of importance. So the first method we learned was factor by grouping. The reason factor by grouping is the most important method is because we can use it for things other than simply solving a quadratic equation. You'll see in later lessons that we can use it to solve polynomial equations that are not, where x squared is not our greatest exponent. Right? And the other methods we've learned would not work, but we can use factor by grouping for those. We can also use factor by grouping to rewrite. We're going to work with functions called rational functions later in the year, and we can use factor by grouping to rewrite those equations and then simplify those equations. So that's why factor, and we can also, not only that, we can also solve more complicated problems and rewrite complicated problems that are not quadratic and are not polynomial using factor by grouping. So factor by grouping is our most important method. Second most important method, and the second method we learned, was solving by taking a square root. It allows us to easily solve quadratic equations where there is no b term, right, by taking a square root of both sides. And we use it for problems that we could not have factored. Right? So for instance, we have a sum of squares. That's not going to be factorable. We can still solve it by taking a square root. We also use solving by taking a square root as part of our next method, which is completing the square. So in addition to solving quadratic equations using completing the square, we can also rewrite quadratic equations into a form that would make it easier for us to graph them. So that's the reason completing the square is so important. And finally, we learned quadratic formula. Its benefit is it's fairly easy. It's not really a very difficult format to use. However, it tends to be the format that students make the most errors with, right? Because they kind of get too comfortable and they forget to be looking for certain things, like properly reducing, combining terms that could be combined, and making errors reducing. And also, quadratic formula really doesn't have any other use other than being able to solve quadratic equations or equations that are quadratic-like. Right? They have a something squared, and we can maybe use quadratic formula for those. Right? But of course, all 4 of our methods are important, and there are times where we're going to use each one of these methods. So because of that, we're going to review all of them, starting with factor by grouping. These are in your notes. And so let's review using factor by grouping to solve. To apply the factoring method, we have to write the quadratic equation in standard form. Does it not say write the quadratic expression in standard form? It says it twice because it's so good. And then using the zero factor property, set each factor equal to 0 and solve the resulting equations for the variable. Right? So remember the zero product property? The equation a times b is equal to 0 is a true statement if and only if a equals 0 or b equals 0. All right, so we're going to solve this one. This one is not in your notes. I have the next one in your notes. All right, so you can just watch me do this one. And so first of all, this is not in standard equation, not in standard form. Right? Standard form looks like this. So it's ax squared plus bx plus c equals 0. So the squared term, the x term, the constant is equal to 0. Now sometimes we might not have an x term or we might not have a constant, but it does still need to have everything on one side set equal to 0. And you can see we've got things on both sides. So we want to move everything to one side, and we don't want to make x squared negative. It is best to keep that positive, and we can always keep it positive simply by making sure we move everything to the correct side. In this instance, the correct side for us is going to be move everything to the left. That will keep x squared positive. So we're going to add an x squared to to both sides. We're going to add a 3x to both sides. We're going to add a 3 to both sides. Right, so, and now we'll have everything on the left side. So x squared plus x squared is 2x squared. 2x plus 3x is 5x. And negative 10 plus 3 is going to give us negative 7. Right? And that's equal to 0 because now there's nothing on the right side. So now we multiply. We multiply a times c. Let's actually write down what a and b and c are. A is equal to 2, b is equal to 5, and c is equal to negative 7. So a times c, actually I don't even have to write parentheses there, but that's okay. A times c is equal to 2 times negative 7, which would be negative 14. Oops, there we go. So and our b term, notice, is 5. So we need two numbers that multiply to give us negative 14, but add to give us 5. Right? Well, that's going to be a positive 7 and a negative 2. And it doesn't matter who goes where. Right? So 7 times negative 2 is negative 14. 7 plus negative 2 is 5. If you wanted, you could reverse those, and then you wouldn't have your term you're pulling out be negative when we use factor by grouping, but it doesn't make any difference. Right? So the way I wrote them is the way I'm going to plug them in. So what we need to do with those terms that we wrote over there is to replace the middle term. Remember, when we multiply a binomial times a binomial, right, an x plus or minus a something times an x plus or minus some constant there, right, we're going to get 4 terms. Right? We get the first term, we get the outer term, we get the inner term, we get the last term. Right? So 4 terms. But then somebody went and combined 2 of our terms because, well, they were like terms and they could do that. We want to get back to the 4 terms so that we can use factor by grouping to undo that multiplication, that distribution process. So we're going to replace that 5x with a 7x and a negative 2x. So we have 2x squared plus 7x plus, this has to be a plus here, negative 2x, that negative has to stay with the 2, and the last term there was a negative 7. So notice we kept the first term, we kept the last term, we just replaced the middle term. And then, because it's called factor by grouping, we group 2 terms and 2 terms. Our goal is to pull out a greatest common factor so that we have, in the parentheses, we have the same factor left. And if we do, then we can factor out that same factor. So from a 2x squared and a 7x, their only common factor is a 7. Excuse me, I said 7, I meant to say x. Their only common factor is an x. And so we'll divide 2x squared plus 7x by x. Make sure that when you write the x down and then actually do the dividing. All right? You don't want this to still say 2x squared, otherwise you've got an untrue statement. Right? It's x times what we get when we divide by 2x squared. Right? That would be a true statement. So 2x squared divided by x, this should be a 2x. Because we factored out an x. And then 7x divided by x, that's 7. Now we want these terms in the parentheses here on the next step, we want them to match. They don't match right now. We have a 2x plus 7 and a negative 2x minus 7. And they don't really have any greatest common factors, except everything is divisible by 1 or negative 1. And if we divide negative 2x minus 7 by negative 1, we have 2x plus 7, and now we do have a greatest common factor that we could factor out from this expression. We can factor out the 2x plus 7, right? Because each of these terms has a 2x plus 7. If we divide x times 2x plus 7 by 2x plus 7, we're left with an x. If we divide negative 1 times 2x plus 7 we divide that by 2x plus 7, we're left with a negative 1. Notice it's the terms that we factored out, the leftover terms, they make up the second factor. And I forgot to write equals 0 the whole way through. So now all we have to do is set those factors equal to 0 and we're done. Right? So 2x plus 7 is equal to 0. We'll subtract 7 from both sides. 2x equals negative 7 and then divide by 2. X is negative 7 halves. And then if x minus 1 is 0, we would add 1 to both sides and x is 1. There is our 2 solutions. All right? So we put it in standard form. We figured out what we should rewrite that middle term as, so that we had 4 terms, because that's what we will have when we multiply binomial together. If you you can always check yourself. If you multiply 2x plus 7 times x minus 1, you will get 2x squared plus 5x minus 7. Right? So we have to get back to the 4 terms, pull out our greatest common factor, and then regroup. Right? So that repeating is one of our factors, and what we pulled out, that becomes the other factor. All right, let's look at the next problem. Now that I went through the steps, I can go through this one a little bit quicker. All right, so this one is in your notes. I want you to do this one along with me. I must have erased it because I know I have it in handwriting on mine and typed on yours. All right, so we're going to put this in standard form, and not only is this not in standard form, we've got parentheses and all kinds of stuff in here. So the first thing we're going to have to do is get rid of the parentheses by distributing the 2x and the negative 6x. All right, so we have 2x times x, that would give us 2x squared. 2x times a negative 8, that would give us a negative 16x. We have a plus 5 here. Negative 6 times x, that's going to give us a negative 6x squared. And negative 6x times 5, that would be a negative 30x. Right? You want to keep your x squared term positive, so you're going to move the negative 6x squared and the negative 30x. So you're going to add 6, oops, I put that in the wrong spot. Add 6x squared to both sides. And add 30x to both sides. All right, so 2x squared plus 6x squared, that's 8x squared. Negative 16x plus 30x, that is 14x. And then we have plus 5 equals 0. All right, so now we multiply. A times c, so a is 8, b is 14, and c is 5. If c had been an even number, we could have divided everything by 2 first, but it's not, it's odd, and so they have no common factors. So a times c, I liked the parentheses, that would be 8 times 5, which is 40. All right, so we need 2 numbers that multiply to give us 40, but add to give us our b term of 14. I think this one's an easy one to figure out. That is 4 and 10. All right, so we'll replace the 14x with a 4x and plus a 10x. So we have 8x squared plus 4x plus 10x plus 5 equals 0. And then the first to our group, make sure there's a plus there. Second to our group, because this is still addition. All right, all we've done is we put some parentheses. We can put parentheses anywhere we want. Right? But these parentheses help us to turn those 4 terms into the product of 2 binomials. Greatest common factor for 8x squared and 4x, that's a 4x. 8x squared divided by 4x is 2x. 4x divided by 4x is 1. Greatest common factor for 10x and 5 is 5. 10x divided by 5 is 2x. 5 divided by 5 is 1. Here you see that repeating 2x plus 1. We can factor that out. So 2x plus 1. And when we factor out the 2x plus 1, we're left with the leftovers. All right? Once we factor out the 2x plus 1, what 2x plus 1 was multiplied, the leftovers goes in the parentheses. So 4x plus 5. And we're done. This one was a pretty easy one, I think. So now we're almost done. We got to set, since we're solving, we got to set equal to 0 and solve. Then we're done. But this part's the easy part. 2x plus 1 equals 0. 4x plus 5 equals 0. You'll subtract 1. So we have 2x equals negative 1. Then divide by 2. X equals negative 1/2. Subtract 5. 4x is equal to negative 5. X is equal to negative 5/4. If writing down the wrong sign is a problem for you because you're going quickly and you accidentally write 1 instead of negative 1 or 5 instead of negative 5, here's a little way you could check yourself. If the factors are plus, so notice this is a plus, when I solve for x, it's going to be a negative. Right? If I have a plus, my factor has a plus, my answer is going to be a negative. If I have a minus, my answer is going to be a positive because I'm going to do the opposite. So that's just a little way you can kind of check yourself. After you get your answers, just kind of look back. I see pluses, my answer should be negative. Because it's easy to accidentally make a sign error. You know what it is, but you accidentally write down the wrong thing. There's factor by grouping. All right, so solving using the square root method. The first one is in your notes. I want you to write down the second one because hint, 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 it's going to come up on a test later. Probably this month, later this month, we'll have a test on, if it's not this month, it's going to be the beginning of September. So make sure you write down that second one as well. It should have been in your notes. I don't know why it's not. All right, so let's solve the first one. If we're using the square root property, right, we want to isolate the x squared, right? Don't take any square roots until you get the x squared all by itself, or the something squared in the case of the problem on the right, right? In this case, it's the x that's being squared. In this case, it's the x plus 3 being squared. So whatever it is being squared, you want that to be isolated before you take a square root. Right? So that means my first step is that I have to add 6 to both sides, right? Because we're going to, it goes opposite of PEMDAS, right? So we do the addition subtraction first. Right? So we're going to add 6 to both sides. That gives us 4x squared equals 25. Divide both sides by 4. Now you have x squared equals 25 fourths. Remember, there's two solutions. If x squared equals k, then x equals the square root of k, or x equals negative square root of k. Because there are two different numbers that if I square them, I'm going to get 25 fourths. Right? So we take the square root. So plus or minus, if you have a quotient, or a fraction is a quotient, split that into 2. So we have 2 radicals. So we have the square root of 25 and the square root of 4. Then you can deal with each one of them separately, because sometimes they won't both be they won't both be perfect squares. In this case, however, they both are perfect squares. 25 is a perfect square and so is 4. So we just take the square root and we are done. X equals 5 halves, x equals negative 5 halves. Perfectly fine to leave it as plus or minus, right, as your two answers. The only time it's not okay to leave a plus or minus is if you have two terms and you could combine them. If you can't combine, if you only have one term, or if you have two terms and you can't combine them, the plus and minus is fine. Let's look at the second problem here. All right, so again, we're going to isolate the something squared. In this case, it's not an x that's being squared, it's an x plus 3 that's being squared. All right, so I'm still going to subtract 6 from both sides as my first step. Negative 1/3 times x plus 3 squared is equal to, so if you subtract 6 from both sides, I now have 9. When we have a term and it's multiplied by a fraction, what you don't want to do is divide by that fraction. Because what students tend to do is this. They go, okay, I'm dividing by 3. That will isolate my 1/3. No, all you did is now you've got 1/9. You don't have just x plus 3. You now have it multiplied by 1/9. What you have to do is multiply by the reciprocal of 1/3. Right? So if you have a fraction, so if I want to divide by 1/3, that's the same as multiplying by the reciprocal, which would be 3. So I'm going to multiply both sides by negative 3. You want that negative 1/3 to cancel. The other side's going to get bigger if you've got a fraction that's less than 1. All right, so now we'll multiply both sides by negative 3. That will cancel out that negative 1/3. So now I have an x plus 3 squared is equal to negative 27. All right, so now we're going to take the square root of x plus 3 squared, the something squared. On the other side, don't forget two solutions, plus or minus negative 27. On the left-hand side, square and square root cancel, that's x plus 3. On the right-hand side, we can simplify. Right? So first of all, I can think of this as 27, square root of 27 times the square root of negative 1. 27 is 9 times 3. 9 is 3 times 3. We have 3 3's, but unfortunately we only need 2. So 1 3 has to stay in radical prison because he doesn't have a buddy. So we have x plus 3 is equal to plus or minus 3. Now before I write that square root of 3, let's deal with the square root of negative 1. Remember, the square root of negative 1 is I, right? That allows us, I there allows us to solve when we have a negative. We have to take a square root of a negative, and we can still solve. So now it's going to be 3i square roots of 3. Make sure the number and the I, the coefficient and the I go in front of the radical. Otherwise, it has a tendency to look like it's under the radical. Now all we got to do is subtract 3 from both sides. Let's put this in the proper form. First, the number, the negative 3, plus or minus, that goes with the 3i square roots of 3. Then the coefficient, the I, and the radical. That's the proper form. Okay? So make sure you put that in the proper form. Right? And it's the plus or minus goes with whatever it is you took the square root of on the other side. Right? And there it is, simplified, looking good. So it took me 20 minutes to get this far, and rather than completing the square and quadratic formula on the same podcast, I'm going to stop this podcast, and so join me in the next podcast, and we'll look at the last two methods, completing the square and quadratic formula. Make sure, by the way, you've got that second problem there added to your notes. You'll see that one again. All right, bye for now.